So hello. So what we are going to learn today is how to prove some mathematical questions. Before we jump into proof by induction, there are certain ways that we can use to prove some mathematical statements. So instead of talking about how to prove, so I found it wise for me to just get examples of such questions, and then we learn by doing. So we are going to do 6 questions. So these are the 6 questions that we are going to attempt. Okay, so the first question is first question is modulus of what? This is the first question. Modulus of A is equal to modulus of A multiplied by modulus of B, like this. So we are going to prove this. Okay, so we are going to, the best way to prove this is to use cases and the definition of modulus. Okay, so case number one. Okay, we're supposed to say A, B are integers. They are integers. I've forgotten the sign of an Z, like this. Okay. Okay, so case number one, for A is less than B is less than 0, sorry, A is less than 0 and B is more than 0. If so, we are going to test for A is less than 0 and B is more than 0. Okay. So what we are basically doing is to put this was supposed to be AB. Okay, AB. Okay, so its modulus of AB is equal to modulus of A multiplied by modulus of B. Okay, so for A is less than 0 and B is more than 0, we are going to substitute in there. Okay, so our left hand side, yes, okay, we are going to say modulus of, we said A is less than 0, negative A multiplied by our B is positive B. Okay, then right hand side will give us modulus of A is negative A, then B is positive B. So if we evaluate this left hand side, we'll be left with modulus of negative AB, which will give us AB. This is our answer. Okay, if we take the modulus, we'll get AB. Then from the right hand side, modulus of A is modulus of A modulus of B. Okay, let's keep the negative for now. So modulus of A of negative A is A, then modulus of B is what? Is B, which will in turn produce A, B, like this. So if you look at this, left hand side is equal to right hand side. So case 1 is satisfied. So let's check for case 2. Case 2. For case 2, we are going to use for A is positive and B is negative. Okay, so left hand side we have A is positive, A multiplied by B, negative B. Okay, then if we multiply this, we'll get negative AB, like this, which will in turn produce AB, like this. So for the right hand side, okay, modulus of A multiplied by modulus of negative B, like this. So if we take the modulus of A, it's A, then the modulus of negative B is B. So our answer will be A, B, like this. Left hand side is equal to right hand side. Okay, so having done this, I think we can conclude that this statement is true for n case, because if we take negative numbers right there, we can go on and say talk about negative numbers and positive numbers. And case 3 and case 4, let's prove for case 3 and case 4. Okay, All right. Okay. For case 3. Okay. For A is more than 0 and B is more than 0. Okay. So A will be positive and B will be positive. Modulus of A multiplied by B, this is the left hand side, is will produce AB like this. We all know this. Then modulus of A multiplied by modulus of B will produce AB, which is correct. So LH, left hand side, is equal to right hand side. Case 4, which is our last case, where we have for A is positive, is negative, and B is negative. Okay, modulus of L, left hand side and right hand side. For the left hand side, we have modulus of A. Our A is what? It's negative A multiplied by negative B, like this, which will in turn produce modulus of AB, which will produce AB like this. Then for the right hand side, we're going to say modulus of negative A multiplied by modulus of negative B, which will then produce A multiplied by B, because modulus of A is A, modulus of B is B, which will produce AB like this. Left hand side is equal to right hand side. Therefore, modulus of AB is equal to modulus of A multiplied by modulus of B is true for AB is an integer, or is an element of an integer, something like this.